Okay. So what is the area of this figure here?
40?
40.
40, it would be a velocity of
Per
40.
second.
The area
Divided by second.
is 8 seconds multiplied by 5 meters per second, right?
Yeah,
Not 40.
40 meters.
It's 40 meters. Okay? Which equals then 40 meters. And what might that represent? So, everybody think a minute and write down what you think that might represent. Okay, now I can't give you too much time because if you happen to watch this video, we don't want to have a lot of dead space. But if you are watching the video, then you would want to maybe pause the video and write down what you think that might mean, rather than looking ahead and getting the answer. Think it through yourself, and if you don't get it, then you get the answer and you think about why. Okay, so now Isaac, you've been answering a lot of questions, so I'm going to let somebody else answer. Okay, Sydney?
From what I thought it would be, like 8 seconds, like if you took the rate of change or the and take it, and it's 8 seconds compared to what that is.
Okay, so it's a rate of change. It's an answer to rate of change question, right?
Mm-hmm.
So you could say, and let's go ahead, just so we can talk about it and use words to refer to it, let's go ahead and say, well, what if we have a y versus x, or y versus t, let's say, because that's in time, so we'll use t, right? Okay, so if the rate of change of y with respect to t is 5 meters per second, then well, actually I got the word then, I should say and delta t is 8 seconds, right? Then delta y equals rate times delta t, and that's 40 meters. That's essentially what you were saying, right? Okay, and that's a really good way to think about it. That's wonderful. Okay? Now out here in the real world, what could that mean? Somebody else. An example. Where could this possibly arise out here in the real world?
Throw something.
Yeah. Can you give her a minute? Okay. Isaac, you apparently have an answer. Nobody else is answering. Go ahead.
Sorry, if you like throw something, I don't know, 5 meters a second seems pretty.
So, okay, well, what's 5 meters per second?
It's a velocity.
It's a velocity. Can you run that fast?
Maybe. I'm not in the metric system.
Yeah, I think
Could I?
typical, 5 meters per second, that comes out to about 11.5 miles an hour. Okay, human beings can run up to 27 miles an hour. Nobody's ever been measured to run faster than 27 point some, but Bob Hayes did it back in the 60s. Usain Bolt went a little faster than Bob Hayes, okay? Usain Bolt also started a little faster than Bob Hayes. He was a slow starter, but he was a world record holder for years. And that's a little color behind it. But 28 meters per second is something over in the vicinity, 12, yeah, I think it's over 12 meters per second, okay? So any healthy person of your age who's not as clumsy as I am could probably run 5 meters per second without a lot of trouble, okay? Yeah. Okay, so, but that's, you know, you'd be running, okay? I can probably still run 5 meters per second on a day when my hip isn't bothering me, okay? But I'm pretty decrepit. So maybe not. Okay, so 5 meters per second for a typical person who's running, you know, you're running. You're not just jogging, you're running. But it's not your maximum speed, okay? So what would this be in terms of running? Means you could run 40 meters in 8 seconds. Okay? Well, you know, go out to a football field someplace with a stopwatch, you can easily run 40 meters in 8 seconds. Okay? Unless you have some reason that you can't run normally. Okay. So that would be like the answer to the question of how far would you run in 8 seconds at 5 meters per second? Constant 5 meters per second. Right? Okay, so what about this one?